We're here learning about section 5.3, points of concurrency. Our objective today, identify properties of perpendicular bisectors and angle bisectors. Okay, today we're just doing perpendicular bisectors. This is day one. Okay, concurrent lines are what we're learning about. And they are lines, three or more lines that intersect at one point, okay, at the same time. A point of concurrency is that actual point where those three lines come together or more. Perpendicular bisector is the perpendicular bisector of a segment of is line, segment, or ray that is perpendicular to a segment at its midpoint. Now remember, we had that yesterday, and we had it in chapter 1. I'm just redoing that definition because we're seeing it yet again. And again, you could take classes here at Elk River High School concurrently in math. You could take geometry and algebra 2 as concurrent classes. You could take them at the same time. There are situations where you have to have prerequisites, like you have to have algebra and expo and before you took geometry. Okay, algebra and expo would be prerequisites to geometry. So you could not take them concurrently at the same time. Okay, so just know what concurrent means. Now, as we're moving on, we're learning about a point of concurrency today called circumcenter. Please put this on top of theorem 5.6 there in your notes. It's called circumcenter. Okay, it is the point. If I were to take a compass and put the pointy part on my point of concurrency called the circumcenter and extend my drawing portion out to a vertex of the triangle, I could spin it around and I would circumscribe the triangle, coming in contact with all the vertices of the triangle in the circle. And I only have to do it once. I wouldn't have to like guess where the center is because that circumcenter would be the center of that circle, because the distance from P to A, P to C, P to B, and that's the same thing here, P to A, P to B, P to C, would all be the same. Okay, that's the mathematical significance of a circumcenter. The circumcenters, from the circumcenter, the distance to the vertices is all the same. Okay, now let's check this out. Theorem 5.6 is the concurrency of perpendicular bisectors theorem. This is the circumcenter theorem. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. The circumcenter has that property. The circumcenter of the triangle is the point of concurrency of the perpendicular bisectors of the triangle. Circumcenter is the equidistant from the vertices. So the center of circumscribing circle that goes through the triangle's vertices. It is the center of the circumscribing circle that goes through the triangle vertices. And that's, we have a picture of that there in the notes. Okay. Now, there are three types of triangles we've worked with: acute, right, and obtuse. In an obtuse triangle, a right triangle and acute triangle, I have shown you the general location of the circumcenter. Inside the acute triangle, it's someplace inside the main part of the triangle. Okay, in a right triangle, it is on the triangle. Specifically, it's always on the midpoint of the hypotenuse of the triangle. So the circumcenter is on the midpoint of the hypotenuse. So you have to identify what type of triangle we're working with. And if it's a right triangle, you can determine what the hypotenuse side is, the longest side opposite the right angle, and then be able to figure out, hey, you know something? It's the midpoint of that hypotenuse. So you need to know how and what to do with the midpoint formula. In an obtuse triangle, it's on the opposite side from the obtuse angle. So it's up here away from the obtuse angle. I'm going to give you a moment to get this down before we move on. Make sure you get these things down. Now, one of the things about this today is I really want to emphasize the importance of diagrams and their markings. There are red marks I have up there that you do not currently have on your diagram. In the acute triangle, you don't have the singles, the triples, and the double markings for tick marks. Those are there to show you that that perpendicular segment or line is coming from the actual midpoint of the side, because that would make it a perpendicular bisector. Please make sure you put those marks in your diagrams right now, okay? And the reason being is because you've got to be really good at noticing these subtle differences between perpendicular bisector and perpendicular, just an altitude, which is a segment that's perpendicular to a side going to the vertex opposite it. It does not have to come from the midpoint. Okay, so we have to be able to recognize the difference between a perpendicular bisector and an altitude. We're going to learn about altitudes tomorrow. Okay, we have to know the difference between a perpendicular bisector and a median. Okay, and the difference between a median and an altitude. So we have to be aware of these things. Today we're working with perp bisectors. Okay, so a perpendicular bisector from each side of my triangle. So from each side of my triangle has a perpendicular bisector. They meet inside the acute triangle. They meet on the midpoint of the hypotenuse of a right triangle. And then they always meet opposite the obtuse angle in an obtuse triangle. Okay, so keep that in mind. This is true of all perpendicular bisectors, the circumcenter, and that's made by the perpendicular bisectors. Now, I've got 5 questions for us to answer. Let's get this cleaned up. Looks like I was pretty busy today. Now, the first thing you got to make sure you recognize is that you know the midpoint formula. And that is the average of x's and the average of y's. I'm going to make that more of a y than an x. Okay. Once you know the average, you got it. But you have to identify the endpoints that we're working with here. Now, keep in mind, all 5 of these questions are here to help us with right triangles, okay? And we just wrote down, we just did a diagram. We found out that in a right triangle, the circumcenter is located on the midpoint of the hypotenuse, right? That's the side opposite the right angle. So when I'm doing problems like 1A, I find my points. I got 1, 3. I've got 6, 1. I am concerned with these 2 points because they are the endpoint of the hypotenuse of my right triangle, because the circumcenter is located on the midpoint of a right triangle. I'm using midpoint formula. I wrote that up. So 1 plus 6, my average of my x's divided by 2. 3 plus 1, my average of my y's divided by 2. Well, I've got 7 divided by 2, which is 3.5, and I got 4 divided by 2, which is 2. So my circumcenter of this right triangle, the midpoint of my hypotenuse, is 3.52. Now, when it is in a right triangle, it's oriented using the horizontal vertical segments or lines of my grid to make my right angle, it's easy to recognize it's a right triangle. But here in B, I've got a triangle that isn't using horizontal and verticals to make my right angle. So I have to determine to make sure it's a right angle before I get going here. And how I do that, I have to recall that perpendicular segments that make right angles have a product of their slopes be -1. And we did that from chapter 3. So if I look at the slope, the rise and run, that's 3, 3, and the rise and run there, and I suppose that would be 3, -3 as I go. If I'm looking for this slope, I've got my rise is -3/3, my run, which is -1. If I look at this slope, I've got my rise over run, which is still 1. Their product, 1 times -1, is -1. So I know that they are perpendicular. So now, because I know they're perpendicular, I can just go, hey, you know, the midpoint of the hypotenuse. This is my hypotenuse. I got to find the midpoint. There's two ways of doing it. I can find the endpoints of that hypotenuse and do the midpoint formula that I just did on A, or I could just recognize it's a horizontal line, right? And it's 6 units long. What's half of 6? And people are thinking, well, 3, Bloom. So right here is my circumcenter, okay? But I have to be able to do it with coordinates. This is my X and Y axis. From 0, 0, I go 0 and down 2. So I am at 0, -2 for my circumcenter there, okay? If you need to, you may find the endpoints of the hypotenuse. You can take the average of the x's, the average of the y's, and you will get the same value, 0, -2. Now, I want you to try this. Your turn. C, find the circumcenter, which is the midpoint of the hypotenuse. Go. And it's not a general thing. It's a specific value that you can find. Now, I found my endpoints. They are the endpoints of my hypotenuse of my right triangle. The circumcenter is the midpoint of the hypotenuse of a right triangle. And I evaluate. -4 plus 0 is -4 divided by 2, -2. 4 plus 0 divided by 2 is 2. Done. Okay. Now I've got 2 problems left. I would like you to plot both triangles on your own. After you finish plotting them, find your mid segments. Shouldn't say mid segments. Find your circumcenter, which is the midpoint of the triangle's hypotenuse you just drew in there. The reason I'm having you plot them is I want you to practice plotting. Make sure you can do it on your own. So go ahead and do problems 2 and 3. Now as we're going, I got the endpoints of my hypotenuse listed, 0, 6, 4, 0. I am just doing the average of the x's, the average of the y's. 0 plus 4 divided by 2, 6 plus 0 divided by 2. And when I do that, that's what I'm getting, 2, 3. Are you okay with 2, 3? Okay, and remember what I did. 0 plus 4 divided by 2, 6 plus 0 divided by 2. That's how that was arrived at. I am using this formula, midpoint formula, to get it done. So once I get my triangle done, I make sure it's a right triangle, and I read my question to make sure that's what I was supposed to find before I move on, and I did. I was supposed to find the circumcenter. So I find the circumcenter here, -2 plus 6 divided by 2, 3 plus -1 divided by 2. Well, that's going to be 4 divided by 2, which is 2, and 2 divided by 2, which is 1. And so I have 2, 1 for my last one. Is it making sense what I'm asking you to do? Okay, now here's the thing. Today, your assignment takes maybe 12 minutes. We have 20 minutes left. In the last 8 minutes, I want you to get on the Schoology and read through the Quizlet for Chapter 5. It's the 3rd thing down in your Chapter 5 folder. Check it out, familiarize yourself with it, practice it, and you're done with today's assignment. You're done with your review, and you can even reread your notes in the time that's left. And then we'll do the same thing tomorrow after tomorrow's assignment, okay? So go ahead, get that stuff going, all right? And we'll talk about any questions you have tomorrow.